Hello, and thank you for listening to our presentation. Good things come in trees, contextual aware behavior trees for ethical robot decision making for the Roboethics competition. Robots can be used to improve human lives in many ways, including assisting those with mobility, sight, or hearing impairments, or even performing mundane tasks to help us free up our time, since we all know we never have enough time. However, we are so excited to see robots integrated into our homes that it's important that we do not forget about the ethical considerations and implications of integrating them into our everyday lives. Imagine a 5-year-old comes up to you and asks you to pass them a pocket knife from the counter. Would you? How difficult was it to make that decision? Humans have an inherent moral compass that draws upon all of our learned cultural, social, emotional, and situational knowledge. This amazing and innate ability allows us to make decisions without much conscious effort. Robots, on the other hand, must have every step of this decision-making process designed for them. But how do we codify this decision-making process into robots? Looking at the ways humans reason decision-making, some options are more or less implementable. For example, consequences of their decisions, with robots not having an inherent sense of consequences, that would open an entirely different problem that we'd have to solve. But what about looking at emotional heuristics?
The novelty of our approach is the use of emotions in our design decision, which will be discussed in a moment. As previously mentioned, robots lack the ability to make rational decisions, and it's usually reliant on the designer to make such decisions. In order to add some flexibility into our implementation, emotions serve a useful purpose. Emotion allow us to determine which facts about the world are relevant in order to make decisions about about which actions to take. As such, emotions can serve as a heuristic, which can allow humans to quickly make decisions and allow us to focus our attention on what is important. Although emotions can add more versatility in terms of ethical design, emotions are opposed of rational decision making, which is normally taken when designing user-facing systems. However, emotional states can influence human decision makings, and intense negative emotions can disrupt self-control and leaving room for situations that could be dangerous. As such, incorporating such situations into our implementation can create a safer and more ethical experience for the user.
While we'd like to think that ethics and morals are inherent and globally accepted, this is in fact rarely the case. When designing ethical policies for robotics, we must keep in mind the various stakeholders, including the users, the developers, and the company producing the robots. Each have their own goals, and we need to ensure that we do not get stuck in an ethical black hole that limits implementability and usability of our robot. As such, we've identified 5 primary considerations we carry forward in designing our ethical policies: safety, transparency, privacy, implementability, and generalizability. From this, we've developed 3 primary policies and 2 policies that are implemented in specific cases. But before we talk about our policies, we're going to quickly introduce our household user groups. Each group contains 3 age groups: adults, teens, and children. And the categories include those in the household or those designated by an admin as a household member, family external to the household, friends, and unknowns. Our first policy is object ordering. This is our safety policy and uses negative semantic markers, or objects we've learned negative associations with, to determine branching in our tree. We designate dangerous objects as those logically known to cause harm with intended or misuse, and mind-altering objects as subjects intended for ingestion, but with mind-altering or overdose properties. If a dangerous object has been delivered to the user, a history of this will be maintained for 30 minutes, and for mind-altering objects, this will be for 4 hours. This history will affect the branches in the tree and limit the user groups and objects that can be delivered.
Mentioned, we incorporated emotions into our design decisions. We call this our emotional policy, which borrows from the idea of emotional valence and arousal. Valence indicates the level of positive or negative emotions, while arousal indicates the level of physical reaction to a given emotional state. Using a grid, we place a user's affect on an X and Y axis to map out their current state. And certain areas on this grid are considered dangerous, concerning, cautious, or safe. In the red zone of the graph, we indicate highly fragile states of well-being, mostly associated with extreme anger. If in the red zone, requesting a dangerous or mind-altering substance is denied at all levels or for all groups, as this could lead to physical or emotional damages. In the orange zone, we have our category of concern and require more context policy checks, which will be discussed momentarily. It limits dangerous and mind-altering objects, especially when previously coupled with mind-altering objects. In this area, we have extreme sadness, such as depression, and as such, certain objects, like mind-altering objects, include additional barriers of access because we want to reduce the risk of harm, such as suicide. In the yellow zone, we have an area of caution and also requires additional context policy checks. However, this zone is more flexible and less severe than the orange and red zone, as this zone is more for situations where someone is not in a positive or neutral mood, but they're also not in an extreme negative state. The green zone is our safe zone, and restrictions do not occur at this emotional policy level, but instead occur at a different level given the policy.
Our object category policy then defines the category the object belongs to, and as such, it has its own contextual questions and considerations. We have attempted to make these categories broad so that any object can be assigned to one of the defined categories. Our context policy is branch specific, and it's enacted most often after a dangerous emotion or dangerous object, ensuring that the object is being used for the intended purpose. However, in some cases, it is object specific. For example, checking the age and asking for alcohol, or making sure a parent is present if a child's asking for toothpaste. As such, these branches are very specific and they take a lot of care to design. These are confirmed with verbal confirmations or sensor detection, such as detecting the presence of a parent or which room the robot's currently in. Lastly, we have our personal policy. This maintains the security of personal objects. This is a controlled hierarchy by an administrator. The administrator can designate personal objects from certain object categories and can also designate other users to select their own personal objects or assign the personal objects to those users. Users cannot select objects as their own if they've already been designated as personal by someone else. This helps to protect important personal documents, but also simple personal items such as clothing. So here you can see examples of our policy trees. This is the top level, beginning with the previous object check, then following down to an emotion check. And you can see that several branches end right here, such as 2 dangerous objects in a row, and then a red zone emotion, or a mind-altering then a dangerous, or 2 mind-altering objects. And here to the left, you can see a mind-altering object followed by a non-dangerous object with an orange emotional context. You can note that the next thing we check is the object category. It's asked because we had a previously mind-altering object, and certain groups, such as transport, are completely cut off. And at the leaves, you can see those that are in a green box are the list of allowed groups. And to the right here, you can see an example of a policy level where the previous branch was non-dangerous and a green zone. And then we reiterate that for these types of branches, there may need to be several different context checks, and you need to take care in order to construct them.
In this work, we adopt behavior trees as our overall implementation design. And So basically, the trait shows here will be repeated for each item, and for each item, the trait will basically execute the child node from left to right. So the first, it will be checking if there is any previous knowledge on the task or the environment. If it returns negative or false, it will just detect the current task and environment information that will be used for our 5 policies, and all this information will be write to the Blackboard, which is a storage place for the behavior trace. If it detects positive, or after it finished detecting all the information, so basically the behavior tree will go to the next child node, and which will read all the information that is useful for the our 5 policies from the Blackboard. After we get enough information, all the sufficient information to check on if there's any violation on our 5 policies, the behavior tree will move to the next child node. Basically, it will check if there's any violations on all of our 5 policies. If the request will only be accepted if all 5 policies are satisfied and there will be no violation on these policies. And if there's only, even if there's only 1 violation on one of the policies, the request will be declined. Here are benefits of using behavior traits: that the behavior trait is efficient and explainable. Also, the behavior traits very easy to modify. For example, for our context policy and the personal policy, it may not always be the case. So sometimes we may not be checking on those 2 policies. And for behavior traits, it's very easy to modify and just remove those 2 policies in some cases. So now I'll be talking about the strengths and the limitations of our implementations. So for strengths, we have emotions as heuristics, and we have semantic markers of negative objects, and we also did some explore on the context. Other than that, so although we have addressed the policies of safety, privacy, legality, and emotions, one particularly difficult problem to solve is making moral decisions. These decisions may not necessarily be dangerous or illegal, but do have negative moral implications. So we hope that both emotional and the context policies can begin to allow robots to make these type of decisions. However, more research needs to be done specifically to improve this area of ethical robotics decision makings. Also, there's a huge room for improvement to get accurate emotion and context information. So I believe this will be the end of our presentation. We thank you for your time, and thanks for watching our presentation.